I'm Mary Bucksign, and my work focuses on understanding skeletal fragility from a biomechanics viewpoint, having my background in mechanical engineering. So the extremely cool thing that's happening on July 8th is that we have been selected by NASA to do an experiment on the last shuttle flight ever. And we are going to be testing the ability of a new osteoporosis therapy to prevent bone loss in animals exposed to microgravity. We actually got interested in this several years ago. A graduate student in my lab, Erica Wagner, developed a model to simulate partial weight bearing so that we could study different conditions of disuse. And we received funding of NASA to develop that model and to explore it. And then came along this wonderful opportunity to have an experiment on the shuttle, and that's happening in collaboration with Amgen, who has developed the molecule, and with a company called BioServe, who does the mission integration and is really helping us through the nuts and bolts of how you actually do a flight experiment, which we don't know very much about, but are learning a lot in the last few months. So astronauts lose a lot of bone in microgravity because they aren't exposed to the normal gravitational forces that we have here on Earth. And so that causes them to lose bone at about 10 times the rate of postmenopausal women. One of the things that's interesting and relevant about microgravity is it's the extreme model of disuse, but there are various forms of disuse that occur in clinical conditions. So people getting less active with aging, cerebral palsy, people who suffer from stroke, have various degrees of inactivity that will cause them to lose muscle mass and bone mass. So here we show a 3D rendering of part of the bone of the mouse after it's been exposed to disuse. It's now predicted that 1 in 2 women and 1 in 5 men will suffer a fracture in their remaining lifetime. And the number of fractures is going to grow 2 to 3-fold due to the overall graying and aging of our population. So we think, and I think this is super critical, to have new therapies that are easier and perhaps more potent than existing therapies and have a good safety profile so that we have options to treat people as they get older and prevent fractures. What I want to show you now is some images from a mouse who's been treated on the left with the sclerostin antibody, and on the right, a mouse treated with a substance that's inactive. And as you can see, the sclerostin antibody was able to build bone even in the face of a disuse model. So we expect we'll see the same kind of thing in our mice that are treated and flying on the shuttle. We were all very excited to be able to be there for the shuttle launch. The mice are already hanging out at Kennedy Space Center, getting used to their new environment. And our team will be leaving the weekend of July 4th, heading down, and we'll do some of those pre-flight measurements in the few days before the launch. And then we will wait for the shuttle to come down 12 days later and make some measurements when the animals land, and then bring back specimens back to the lab. What we hope to learn when the mice come back from space, number one is, even in the animals that aren't treated, is what are the effects of microgravity on the skeleton and on the muscle, and how do they interact? And also, will this new therapy be able to counteract those profound effects of microgravity and actually promote bone gain in the environment of microgravity? NASA is very concerned about that and its impact that it may have on long-term spaceflight and exploration class missions. We're particularly excited to be able to study this novel therapy in the microgravity environment, but also knowing that it has application here on Earth.